Hello students, let us go through some more sums based on the variables in the denominator, right. The sum is 2 upon x plus 2 upon 3y is equal to 1 upon 6 and 3 upon x plus 2 upon y is equal to 0. Again variables in the denominator, again because there is no xy term in the denominator, we can't multiply throughout by xy. Option left here is again substituting the common term, the common denominator, right. So let's do it. The equations given are 2 upon x plus 2 upon 3y is equal to 1 upon 6 and 3 upon x plus 2 upon y is equal to 0. 2 upon x plus 2 upon 3y is equal to 1 upon 6 can also be written as 2 bracket 1 upon x, 2 upon 3 bracket 1 upon y. So 3 goes along with 2. It's like separating the numbers and the variables. Remember this is equal to 1 upon 6. Let this be the first equation. The second equation is 3 into 1 upon x plus 2 into 1 upon y is equal to 0. Again the common terms are 1 upon x and 1 upon y. So let us substitute 1 upon x as m and let us substitute 1 upon y as n in the two equations, that is equation 1 and 2. Let's do it in the first equation first. In place of 1 upon x just write m and in place of 1 upon y just write n. So what we get is 2 m plus 2 upon 3 n is equal to 1 upon 6. Now again there are denominators, but this time there are numbers in the denominators. The denominator is 3 and 6, so we need to multiply throughout by 6, the LCM, something which we have learnt, right. So let's multiply throughout by 6. What we get is 6 into 2m plus 6 into 2 upon 3n is equal to 6 into 1 upon 6. 3 2s are 6 gets cancelled, 6 1s are. So what we get is 12m plus 4n is equal to 1. Let this be your third equation. Now let's do the substitution part in the second equation as well. So what we will get, 3m plus 2n is equal to 0. Let this be the fourth equation. Now look at the third and the fourth equation, two simple linear equations in two variables. Let us use the method of equating the coefficients to solve them. Equating the coefficients, we know it really well, so we can just quickly rush through it, right. Again look at the coefficients of m, the coefficients are not the same. Look at the coefficients of n, the coefficients are not the same. So we cannot eliminate either of them right now. Now let's decide which variable it is easier for us to eliminate. For m it is 12 and 3 the coefficients. For n it is 4 and 2 the coefficients. I think it is easier to make the coefficients of n same and eliminate n, right. Let's do that. Let's make the coefficient of n same, and for that we will have to multiply the fourth equation by 2, right. So multiplying equation number 4 by 2, what do we get? We get 3 into 2, that's 6m. 2 into 2, that's 4n, is equal to 0 into 2 is 0. Let this be equation number 5. So we have multiplied the fourth equation by 2 and we have got the fifth equation. So now whatever operations we will have to do is between the third and the fifth equation, because in third equation and fifth equation we have managed to make the coefficients of n same, right, 4n 4n. Now we need to either add the two equations or subtract. For that we need to check the signs of 4n. Here it is plus 4n, even in equation 5 it is plus 4n, the signs are same, so we need to subtract. Let's subtract 5 from 3. When we subtract equation 5 from equation 3, you need to write the third equation first, then you need to write the fifth equation, and now you need to subtract. So let's subtract. Change the signs, the plus sign will become minus, plus will become minus, and plus will become minus. So 12m minus 6m will be 6m, 4n 4n gets cancelled, and 1 minus 0 is 1. You get 6m is equal to 1, so m is equal to 1 upon 6. Once you get the value of m, now it's time for us to find the value of n, and for that you need to substitute m in either of the two equations, either in the third equation or in the fourth equation. The choice is yours. Say if we substitute m is equal to 1 upon 6 in the third equation, what we get? We get 12. In place of m, let us substitute 1 upon 6. So you get 12 into 1 upon 6 plus 4n is equal to 1. 6 2s are 12, you get 2 plus 4n is equal to 1. You get 4n is equal to 1 minus 2. you get 4n is equal to minus 1. So, you get n is equal to minus 1 upon 4. You get the value of m as 1 upon 6, you get the value of n as minus 1 upon 4, but the sum is not yet over. Why? Because we are not interested in the values of m and n, we are interested in the values of x and y. And for that, as we all know, wherever there is a substitution, there has to be a resubstitution. So, let us resubstitute the values of m and n. M is 1 upon x. So, in place of m, now it will be 1 upon 6. So, what you get is 1 upon x is equal to 1 upon 6, right, because the value of m is 1 upon 6. So, what we get is 1 upon m is equal to 1 upon 6 and 1 upon y is equal to minus 1 upon 4, because the value of n is minus 1 upon 4. 1 upon x is 1 upon 6. Let us take the reciprocal or cross multiplication, whatever, you get x is equal to 6, because we are ultimately interested in the value of x and not 1 upon x. So, you need to take that reciprocal, invertendo, or cross multiplication, whatever you are more comfortable with. And 1 upon y is equal to minus 1 upon 4. So, invertendo, you get y is equal to minus 4. X is 6, y is minus 4. Just write the final answer that the solution of the given simultaneous equations is x comma y, which is equal to 6 comma minus 4. As simple as that.